tension in the room is almost unbearable now. Every second stretches, every movement amplified by the unspoken awareness that something extraordinary is happening. Humans, brilliant and analytical, are being outpaced by instinct, by evolution itself. It's a confrontation with humility, a silent reminder that intelligence wears many faces, and sometimes the smallest and quietest are the deadliest. The spider doesn't hesitate, doesn't stumble, and yet it seems to anticipate every move, every hesitation, every human miscalculation. Watching it, you can't help but feel that you are witnessing a quiet rebellion against centuries of human assumptions. Now let's examine the core of what's happening. The spider's brain, though minuscule, operates with unparalleled efficiency. Neural pathways are compressed, optimized for immediate response and flawless execution. Each sensory input is processed simultaneously, giving the spider a kind of hyper-awareness humans can't replicate. Humans, on the other hand, juggle too many variables consciously and subconsciously, introducing delay, hesitation, and error. And in this controlled environment stripped of advantage, the spider's instincts are not just sufficient, they are superior. Every calculation it performs is a testament to the power of evolutionary refinement, a tiny machine perfected over millions of years to survive, adapt, and conquer in its niche. And the suspense escalates further. The test introduces unpredictable elements, sudden shifts in the target's path, new barriers, and deceptive cues designed to challenge adaptive reasoning. Humans strategize, analyzing probabilities and formulating plans, but each step takes precious milliseconds. The spider responds instantly, adjusting its trajectory mid-motion with fluidity that seems almost supernatural. There's no deliberation, no second-guessing, no wasted energy. It is pure efficiency, a dance of life and calculation that humans can only watch in awe. The realization hits slowly, then with force. Raw computation, precision, and instinct can rival, and in some cases exceed, conscious reasoning. Let's not forget the sensory dimension. Spiders perceive their world in ways that humans cannot imagine. Vibrations in the air, subtle changes in surface tension, minute shifts in light, all of these inputs are processed and acted upon instantly. When a target moves unpredictably, the spider doesn't just react, it predicts. It recalibrates mid-strike, adjusting every tiny movement to optimize success. Humans, reliant on conscious processing, are slower, more cumbersome. And in the context of this experiment where milliseconds determine outcomes, the spider's advantage is not just measurable, it's undeniable. It is, in a sense, a masterclass in minimalist intelligence, where fewer neurons achieve more than the human brain in specific high-pressure tasks. But the story doesn't end there. The humans observing this performance begin to question not just their abilities, but the very definition of intelligence. If a creature with a brain smaller than a pea can outperform a human in real-time problem-solving, what does that say about the metrics we use to judge thinking? Are humans truly the apex intellect? Or have we been blinded by our own scale, complexity, and capacity for abstraction? The spider forces a confrontation with uncomfortable truths. Intelligence is not linear, not universal, and not exclusive to humans. It is context-specific, adaptive, and, at times, hidden in the most unexpected forms. Now let's explore the implications for our understanding of cognition. Spiders are not just executing pre-programmed behavior. They are learning from the environment, adjusting strategies, and optimizing outcomes in ways that mimic advanced computational models. Humans, despite years of training, education, and cultural knowledge, are sometimes slower and less efficient in high-stakes, real-time scenarios. This is a lesson in humility, yes, but also a revelation. Evolution has created forms of intelligence that operate beyond human comprehension, forms that are shockingly effective in their domain. Watching this tiny creature outperform humans is a reminder that brilliance is multifaceted, often counterintuitive, and rarely confined to familiar scales. The suspense intensifies as the final stages of the test approach. The spider faces its most unpredictable challenge yet, a target that shifts erratically, barriers that appear and disappear, and environmental factors designed to test adaptive reasoning. Humans attempt to strategize, to predict, to outthink. but the spider responds with instantaneous precision. Every leap, every adjustment, every strike is executed flawlessly. Observers can feel the tension, the quiet awe, the growing disbelief. The spider isn't just surviving. It is excelling in a domain humans assumed was theirs to dominate. And in that stark cinematic contrast, the truth becomes undeniable. Intelligence is not a single measure, not a hierarchy with humans at the top. It is diverse, adaptive, and sometimes hidden in the smallest corners of the natural world. Finally, consider the emotional resonance of this experiment. It's more than science. It's a confrontation with our assumptions, a moment that challenges ego and pride. Humans are creatures of self-awareness, language, and reflection. Yet here is a creature with a fraction of our neural capacity outperforming us in raw, adaptive intelligence. It's humbling, it's unsettling, and it's profoundly instructive. The spider forces us to see that intelligence is not only about knowledge or reasoning, it's about execution, prediction, adaptability, and the ability to act flawlessly under pressure. And sometimes the smallest brains hold the greatest lessons. Hello guys, welcome to another video. Today we're diving into a question that most people would never dare to ask out loud because the answer might just shatter everything you thought you knew about intelligence. Can a spider brain? Yes, the tiny 8-legged predator you've probably squashed in a corner of your room, actually outthink a human being? At first it sounds absurd, but the deeper you go into the mechanics of the mind, the more unsettling the possibility becomes. The brain of a human is, on paper, a marvel. Billions of neurons firing in perfect synchrony, creating thought, memory, emotion, and innovation. But intelligence isn't just about complexity. Sometimes it's about efficiency, adaptability, and instinctive genius. And that's where the spider enters the stage, small, silent, and shockingly precise. Let's start with the basics. Spiders have tiny brains, often just a fraction of a millimeter across. Yet they perform tasks that would leave even sophisticated AI systems scratching their proverbial heads. Orb-weaving spiders, for instance, can calculate tension, trajectory, and angles in real time as they spin webs that are both traps and architectural masterpieces. Each thread is perfectly placed, able to absorb impact, hold weight, and ensnare prey without collapsing. This isn't learned behavior in the way humans study physics. This is encoded, instinctive logic. Millions of years of evolution compressed into a fraction of a cubic millimeter of tissue. Meanwhile, humans, with all our knowledge and reasoning, often fail at things the spider accomplishes effortlessly. Could it be that our notion of thinking is biased, human-centric, and blind to other forms of intelligence? Now here's where it gets even more fascinating. Scientists have run tests that attempt to measure decision-making, problem-solving, and learning across species. The results are unsettling. A spider faced with a complex maze or shifting web anchor points doesn't get flustered. It doesn't hesitate. Every movement is deliberate, optimized, efficient. Humans, on the other hand, with our enormous brains, get distracted, overthink, second-guess, and sometimes make decisions that reduce efficiency by 50%, even in controlled environments. What does this say about raw neural efficiency? Could it be that the spider, with its fraction of a gram brain, is achieving a level of computational efficiency that humans cannot touch, even with decades of formal education? But efficiency is only part of the story. There's also the concept of predictive intelligence. Orb weavers, jumping spiders, and trapdoor spiders all exhibit predictive behaviors that seem, at first glance, almost precognitive. They adjust their hunting strategies based on prior experiences, subtle environmental cues, and even the anticipated actions of their prey. A jumping spider, for example, calculates trajectories with astonishing accuracy before even making a single leap, factoring in distance, angle, and momentum. Humans may do the same calculations subconsciously when catching a ball, but spiders do it without years of practice, without conscious thought, and with a brain thousands of times smaller than ours. The deeper we investigate, the more it feels like spiders are living proofs of an intelligence that humans undervalue, one that is hyper-focused, surgically precise, and devastatingly effective. And now comes the test, the moment where theory collides with reality. Researchers constructed an experiment that sounds like science fiction. They set a spider against a human in a controlled, problem-solving environment. The task was simple in description, but fiendishly complex in execution. Retrieve a moving target that changes position unpredictably, with obstacles requiring both planning and reflexive adaptation. Humans entered the lab confident, armed with strategy, logic, and calculation. The spider, of course, made no plans, uttered no doubts, and showed no sign of awareness beyond instinct. Yet as the clock ticked, something extraordinary began to unfold. Within minutes, humans fumbled, overthinking, re-strategizing, sometimes abandoning approaches entirely. The spider, however, moved with an eerie certainty. Each movement calculated, each adjustment seamless. It adapted to every shift in the environment almost instantly. Neural recordings from the human participants showed spikes of stress and decision fatigue, while the spider's responses were consistent, optimal, and shockingly fast. The humans, creatures of intellect, language, and culture, were being outperformed in real time by a brain that fits on the tip of a pencil. At this point, it becomes impossible to ignore the stark reality. Intelligence isn't measured by size, by language, or by our ability to write novels or build cities. Sometimes intelligence is pure, adaptive, instantaneous problem-solving. And in that very moment, the spider was proving something profoundly unsettling about the hierarchy we've assumed in the natural world. The implications are staggering. If such a tiny brain can outperform humans in specific scenarios, what does that mean for our understanding of cognition? What does it suggest about the untapped potential of instinct-driven intelligence versus conscious reasoning? Are we blinded by our own definitions of intelligence, failing to see the brilliance in creatures we dismiss as insignificant or even frightening? And perhaps most provocatively, if a spider can outthink a human in measurable ways, what does that mean for the future of artificial intelligence, biomimicry, and the limits of our own brain power? Even more unnerving is the way spiders combine speed with adaptability. Unlike humans who often rely on learned rules or trial-and-error approaches, spiders process information almost instantaneously. They don't need to remember every failed attempt. Their reactions are wired for survival, predicting outcomes faster than conscious thought could ever manage. When a prey item zigzags unpredictably, a spider doesn't recalculate consciously. It instinctively anticipates the next movement, adjusts its trajectory mid-air, and strikes with a precision that no human reflex, no matter how trained, can match. It's as if nature has optimized their tiny neural network for specific tasks, while human brains, magnificent though they are burdened by distractions, self-doubt, and extraneous information. And that's the core of the revelation. Humans are complex, adaptive, creative, but not always efficient. Spiders are simple, instinctive, and ruthlessly efficient. Efficiency can outmatch raw computational power when the stakes are survival and the environment is unpredictable. In other words, evolution didn't make humans the ultimate problem solvers. It made us versatile, creative, and reflective. Spiders, on the other hand, were designed to be precise, fast, and deadly in their domain. But when you isolate the task, strip away human advantages like planning, knowledge, and tools, and put raw, real-time problem-solving to the test, spiders can, and do, win. So as we stand here on the threshold of understanding, staring at the elegant, calculating movements of a creature smaller than our fingernail, one question lingers in the air like a whisper we can't ignore. Are humans really the smartest species on the planet? Or have we just mistaken scale and self-awareness for ultimate intelligence? What we're witnessing isn't just a spider beating a human in a game. It's a challenge to our entire conception of thought, reason, and survival. And it forces us to confront something that's deeply uncomfortable. Intelligence is not linear, and it is not exclusively human. Sometimes, the most shocking brilliance is hidden in places we least expect, wrapped in silk and moving silently across a web we barely notice. The room feels smaller now, charged with a quiet electricity. Every eye is glued to the spider, every movement of its legs magnified by our collective astonishment. Humans, despite all their reasoning, all their planning, can't shake the sense that they're being outmaneuvered by a creature whose brain is barely a speck. It's a humbling, almost eerie realization. Intelligence, as we define it, may be far more diverse than we allow ourselves to see. The spider doesn't know philosophy, doesn't ponder existence, and yet it solves problems with a purity of logic that humans can only aspire to in theory. Here's where it becomes truly mind-bending. Spiders are not just reacting, they are predicting. Every motion, every shift, every tiny twitch in their environment is processed, interpreted, and acted upon almost instantaneously. Jumping spiders, in particular, exhibit an uncanny ability to calculate distances, velocities, and angles in real time, adjusting mid-leap to compensate for unexpected changes. Humans, with all their conscious reasoning, often overcompensate, misjudge, or hesitate. It's as if the spider is operating on a higher plane of instinctual computation, a form of intelligence that doesn't need deliberation because it's optimized for immediate survival and flawless execution. Watching it is like witnessing a live equation unfolding, one that humans cannot compute fast enough to keep up. And yet, the spectacle is more than just numbers and neural pathways, it's profoundly emotional. There's a creeping unease that grips everyone in the room, a quiet tension that whispers of a world where the hierarchy we've long assumed might not be absolute. Humans have always considered themselves the pinnacle of intelligence, the measure against which all other creatures are compared. But the spider challenges that assumption. It reminds us that intelligence is not linear, not defined solely by size or complexity, and not always visible in the ways we expect. Sometimes brilliance is silent, precise, and terrifyingly efficient. The experiment escalates, obstacles shift, targets move unpredictably, and humans struggle to adapt. Their brains, remarkable though they are, falter under the pressure of real-time adaptation. Every hesitation costs them precious milliseconds. Every second is a chance for the spider to demonstrate its superior instinctive intelligence. And it does. Time after time, it adjusts, adapts, and executes with a precision that seems almost preternatural. Observers begin to murmur, the tension in the air thickening. The humans are fighting not just a test. They are grappling with the unsettling notion that intelligence might manifest in ways we've dismissed, underestimated, or failed to recognize entirely. The science behind this is both elegant and unsettling. Spiders rely on decentralized neural networks, allowing them to process multiple streams of information simultaneously. Motion, tactile feedback, vision, and spatial mapping all occur in parallel. Humans, in contrast, often process sequentially, juggling competing thoughts and strategies. This gives us creativity, but it also introduces vulnerability. The spider's simplicity becomes its strength, the human brain's complexity, its weakness. It's a brutal reminder that raw size or conscious thought does not always equate to superiority in specific tasks. Evolution, in its quiet, relentless way, has optimized the spider for the challenges it faces, and those optimizations are staggering in their effectiveness. And yet, there's another layer. Spiders possess a form of situational memory, subtle and almost invisible, which allows them to learn from the environment. They adjust hunting strategies, recalibrate angles, and even exploit predictable behaviors in prey. It's not memory in the human sense with nostalgia or conscious reflection. It's embedded, instinctive learning. Humans, by contrast, must consciously track information, analyze, and then act. In high-pressure, split-second scenarios, this often becomes a liability. The spider's brain, minimal as it is, achieves efficiency that human cognition cannot match. In essence, evolution has compressed survival, prediction, and flawless execution into a fraction of the neural tissue humans rely on for far less efficient results. The atmosphere grows almost cinematic in intensity. You can feel a shift in perception, an internal recalibration of what we consider intelligence. Every twitch of the spider's legs, every calculated adjustment, is a reminder that we may have been blind to an entire spectrum of cognitive brilliance. Humans may dominate in creativity, in art, in technology, but in real-time calculation, prediction, and adaptive execution, the spider is a master. The revelation is not just academic, it is visceral. Watching it is a confrontation with the humility we rarely allow ourselves, a reminder that our supremacy is context-dependent, fragile, and sometimes illusory. Now consider the implications. If a spider can outperform humans in tasks requiring immediate adaptive problem-solving, what does that suggest about intelligence as a universal concept? Is human thought simply one form among many? Are there creatures whose brilliance we overlook because it doesn't resemble our own? And when we look at artificial intelligence designed to mimic or surpass human cognition, are we perhaps missing lessons that spiders and other creatures have perfected over millions of years? The answers are as unsettling as they are fascinating. Intelligence is multifaceted, context-sensitive, and often hidden in forms we fail to recognize until we are confronted with them head-on. Finally, let's talk about the psychological dimension. The humans in the experiment aren't just losing, they're experiencing cognitive dissonance. They've spent lifetimes believing in the superiority of human intellect, and here is a tiny creature, operating on instinct, demonstrating problem-solving capabilities that outstrip their own in specific measurable ways. It's humbling, it's disturbing, and it's transformative. For anyone watching, it forces a confrontation with the uncomfortable truth. We are not always the apex problem solvers we imagine ourselves to be. In some arenas, efficiency, instinct, and adaptability, qualities often underestimated, can surpass conscious reasoning in astonishing ways. The room grows quieter still, but the intensity is palpable. Every eye remains glued to the spider, every movement magnified in slow motion by the mind's own fascination. Humans, masters of logic, creativity, and language, are suddenly reduced to observers, watching their assumptions crumble in real time. The spider doesn't know theory. It doesn't ponder philosophy. It doesn't hesitate. It simply calculates, executes, and adapts. The elegance of its motion, the precision of its responses begins to feel almost alien, as if intelligence itself can exist entirely outside human comprehension. Now consider the question that's been silently echoing throughout this experiment. What does it mean to outthink someone or something? Humans measure thought by conscious reasoning, problem-solving, and reflection. But the spider operates on a level that bypasses all conscious deliberation. It perceives, predicts, and reacts with such accuracy that it almost seems as if it's anticipating the future. When a target moves erratically, the spider doesn't chase blindly. It intercepts with preemptive strikes, adjusting mid-attack with a fluidity that humans cannot replicate. It's not magic. It's biology. A brain compressed into a minuscule volume, yet astonishingly powerful within its own domain. And the tension escalates further. Obstacles shift more rapidly, targets move unpredictably, and humans scramble to respond. Calculations that would take a conscious mind several seconds are done instinctively by the spider in milliseconds. Each human misstep is magnified, every hesitation punished. The spider, serene and unwavering, moves with a kind of ruthless logic that borders on terrifying. Observers lean in, unconsciously holding their breath, captivated by a living demonstration of precision intelligence that feels almost cinematic, almost impossible, yet undeniably real. But it's not just about speed or reflex. The spider exhibits a level of environmental awareness that borders on prescience. Its hairs detect vibrations, its multiple eyes capture subtle shifts in motion, and its tiny neural circuits process it all in harmony. It knows where to go before the movement occurs, anticipating challenges that humans struggle to perceive in real time. Each leg movement is a calculation, each adjustment a response to multiple inputs converging simultaneously. In essence, the spider has mastered multitasking at a level humans can only dream of, an intelligence optimized for efficiency, prediction, and flawless execution. The psychological impact on the human participants is staggering. Confidence wavers. The mind races, attempting to reconcile what it sees with what it believes about intelligence. There's a creeping sense of inadequacy, a humbling realization that brilliance is not reserved for those with large, complex brains. Humans may invent tools, build empires, and create culture, but the spider embodies a raw, uncompromising form of problem-solving that thrives in immediacy, precision, and instinct. Watching it perform is a confrontation with the uncomfortable truth that we may have vastly underestimated forms of intelligence that are not our own. And here's where it becomes truly mesmerizing. The spider's movements create a rhythm, a cadence that feels almost musical. Each strike, each adjustment, is executed with perfect timing, as if it's playing a complex symphony of survival. Humans, despite conscious effort, are always a step behind. Reflexes falter, overthinking slows them down, and stress clouds judgment. The spider doesn't experience hesitation, stress, or second-guessing. Its decisions are clean, direct, and brutally efficient. And in this stark contrast, a revelation emerges. Intelligence is not just measured in knowledge or reasoning. It is measured in the ability to act effectively under pressure, in real time, and without error. The experiment pushes further. The obstacles become more complex, the target more unpredictable. Humans attempt strategies, plan contingencies, and analyze potential outcomes, but the spider adapts instantly, adjusting its path with subtle shifts that seem almost pre-programmed, yet are the product of instinctual intelligence honed over millions of years. It's not luck, it's evolution in action. And with every successful maneuver, it becomes harder to deny the shocking truth. In certain contexts, a spider brain, small and instinct-driven, can outperform human cognition. It's not just a challenge to human supremacy. It's a paradigm shift in our understanding of what intelligence can be. And the tension is almost unbearable now. You can feel it in the air. The quiet gasps, the held breaths, the subtle sway of observers leaning closer to watch every detail. Humans glance at each other, incredulous, as the tiny predator continues its flawless execution. The lesson is unmistakable. Complexity does not always equal superiority. Conscious thought does not always equal speed. Reflection does not always equal effectiveness. In the realm of immediate, adaptive problem-solving, the spider operates with a perfection that humans cannot touch. And that realization, quiet yet profound, begins to sink in. Finally, consider the philosophical implications. We have long assumed that the human brain represents the pinnacle of intelligence, a measure against which all other forms are judged. But what if intelligence is not a hierarchy? What if it is multidimensional, context-dependent, and manifest in forms we barely comprehend? Watching a spider navigate, calculate, and succeed with minimal neural resources challenges our very definitions. It forces a confrontation with humility, awe, and a kind of reverence for life's adaptability. The spider, in its small, silent way, is revealing truths that humans have been blind to. Truths that question the very notion of supremacy, creativity, and thought itself. The final moments of the experiment feel almost surreal. The humans lean forward, eyes wide, hearts racing, fully aware that what they are witnessing challenges centuries of assumptions. Every move of the spider is precise, calculated, and yet fluid, a dance of instinct and logic that seems impossibly advanced for a brain smaller than a grain of rice. The humans make last-ditch efforts, strategizing frantically, adjusting plans, trying to predict, to outmaneuver. But the spider remains unshakable. It doesn't pause, it doesn't falter, it doesn't think in the way humans do. And in this relentless execution, it becomes clear. The spider is not merely participating in this test, it is dominating it. Now step back and consider the implications. For so long, human intelligence has been considered the apex, the ultimate measure of problem-solving, reasoning, and creativity. But here, stripped of tools, stripped of time for reflection, stripped of the comforts of conscious deliberation, humans falter. The spider thrives. It navigates complexity instinctively, calculates outcomes in milliseconds, and adapts flawlessly to unexpected changes. It's a form of intelligence that does not rely on ego, on self-awareness, on reflection. It is pure, optimized, lethal efficiency. And watching it, one cannot help but feel a profound sense of awe, tinged with unease. This experiment, in all its suspense and drama, is not just about proving that spiders can outthink humans in specific scenarios. It is about forcing us to question our entire understanding of intelligence. The human brain is magnificent, yes, capable of abstract thought, language, and invention. But it is not omnipotent. It is limited by processing speed, stress, hesitation, and cognitive biases. The spider's brain, small and instinct-driven, achieves in seconds what humans struggle to accomplish in minutes, hours, or even years. The lesson is unsettling. Supremacy is not guaranteed. Context defines advantage. And brilliance exists in forms we have long underestimated. As the final seconds tick away, the humans watch in silence, their minds struggling to reconcile what they see with what they believe about cognition. The spider moves one last time, striking with flawless precision, completing the task without hesitation, without error, and without pause. There is no fanfare, no celebration. It is just the quiet, undeniable proof that instinct, efficiency, and adaptive intelligence can surpass conscious reasoning in specific domains. And in that moment, a truth crystallizes. Human intelligence is not the only intelligence. It is not the ultimate measure. And sometimes, the most shocking brilliance is hidden in the smallest and quietest corners of nature. The aftermath is cinematic in itself. Researchers step back, taking notes, recording data, and yet the impact is felt not in numbers alone. It is felt in the mind, in the creeping realization that intelligence is not linear. Humans, with all their reasoning, creativity, and culture, have been humbled by instinct, by evolution, by the tiny spider brain that moves with perfect, terrifying precision. The experiment concludes, but the lesson lingers. Mastery, efficiency, and adaptation are forms of intelligence just as profound as knowledge, reflection, and innovation. And in certain circumstances, they can surpass human thought entirely. So what do we take away from this? First, humility. We are not the absolute apex of cognition. Second, awareness. Intelligence is multifaceted, manifesting in forms we rarely notice or understand. Third, inspiration. The spider demonstrates a level of optimization and efficiency that we can study, learn from, and even emulate in technology, AI, and problem solving. And finally, curiosity. If such brilliance exists in a creature so small, how many other forms of intelligence have we overlooked in the natural world? How many lessons are hidden in creatures we dismiss as insignificant or frightening? And as we end today's journey, one thing is certain. The line between human and non-human intelligence is far more complex, more nuanced, and more astonishing than we have ever imagined. The spider may not build civilizations, compose symphonies, or debate philosophy. But in the raw arena of survival, calculation, and adaptive problem solving, it is a master. And it teaches us that intelligence comes in many shapes, sizes, and forms. The real shock is not that a spider can outthink a human in specific tasks. It is that we are only beginning to understand the vast spectrum of brilliance that surrounds us every day, quietly, invisibly, in the most unexpected places. Thank you for watching. And if this video shocked and amazed you as much as it did the humans in the experiment, make sure to hit that like button, share it with your friends, and don't forget to subscribe for more incredible mind-bending stories. Leave your thoughts in the comments. Would you have ever imagined a spider could outthink a human? Let's start the conversation. Until next time, stay curious, stay amazed, and keep questioning the world around you. The room is quiet now, but the tension is thick enough to taste. You can feel it in the way the humans hesitate, fingers hovering, eyes darting from one obstacle to the next. The spider, barely the size of a coin, moves with the calm of a master strategist, a predator in its element. Every tiny leg adjusts, every subtle shift calculated without pause. It's a rhythm you can almost feel, a pulse of instinct so precise it makes you question everything you thought you knew about thinking. The humans are watching, but they're already losing. Not just the contest, but the illusion of dominance they've carried for centuries. There's something hypnotic about the spider's focus. It doesn't rush, it doesn't panic. Even when a barrier suddenly drops in its path, forcing a last-second recalculation, its movement is fluid, almost graceful. Scientists have spent decades studying reaction times, neural processing, and decision-making. They've mapped the human brain in ways that reveal every surge of adrenaline, every flicker of thought. And yet, here is a creature whose brain weighs less than a fraction of a gram, navigating chaos with a level of precision that defies all conventional logic. Watching it, you can't help but feel a creeping sense of unease. The spider is not just surviving, it is thriving in ways we are only beginning to understand. Now let's talk about problem solving under pressure. Humans excel at abstract reasoning, creative thinking, and synthesizing information from multiple sources. But when speed, adaptability, and precision are tested simultaneously, that advantage begins to erode. Our complex cognitive processes, which allow us to plan cities and launch rockets, also slow us down in microseconds, where instinct reigns supreme. The spider, in contrast, is pure computation for survival. Every movement, every adjustment is a calculation honed by millions of years of evolution. It doesn't need language, culture, or theory. It needs results. And in the arena of real-time decision-making, those results are often more effective than our best efforts. You might be thinking, but humans can learn, adapt, and invent tools. True. But in this experiment, tools are stripped away. Knowledge, strategy, and logic are tested against immediate, unpredictable challenges. The humans try to anticipate, to control, to strategize, but each hesitation costs time. The spider responds instantly, shifting patterns, adjusting angles, and striking with perfect timing. The contrast is striking. One species hesitates, debates, second guesses. The other acts, calculates, and executes flawlessly. The score isn't just in speed, it's in flawless execution under stress, a domain where human cognition falters while spider instinct shines. Let's zoom in on the mechanics of the spider brain. Unlike humans, whose cortex dominates complex reasoning, spiders rely heavily on decentralized neural networks. Their brain and ventral nerve cord work in tandem, allowing multiple processes to occur simultaneously. Vision, movement, tactile sensing, and web manipulation all happen in parallel, with astonishing coordination. Humans, by contrast, often process sequentially, mentally juggling priorities in ways that introduce error and delay. In real-world terms, the spider's neural architecture allows it to predict outcomes, respond instantly, and optimize every action without conscious thought. It's an intelligence designed for action, not reflection, and that's exactly why it can outperform humans in tasks that demand speed, adaptability, and precision. But there's more. Spiders are also masters of sensory integration. Their vision, while not as sharp as ours in terms of detail, detects motion and depth in ways that make humans seem clumsy. Tiny hairs across their legs act as tactile sensors, detecting vibrations, airflow, and even minute changes in pressure. When a target moves unpredictably, a spider doesn't just see it, it senses it, calculates the trajectory, and launches an attack before a human eye can fully register the motion. It's like watching a living algorithm unfold, an organic supercomputer designed for hunting, survival, and flawless execution. Humans may have imagination, but spiders have execution perfected. And in the arena of raw, real-time problem solving, execution is king. The suspense builds as the humans try to catch up. They re-strategize, eyes flicking to notes, pens tapping, brains whirring, but each calculated move falls just short. The spider doesn't hesitate, doesn't plan, doesn't falter. The contrast is a visceral lesson in the limitations of human cognition versus the streamlined, lethal precision of instinctive intelligence. Every second that passes reinforces an uncomfortable truth. Size does not equal supremacy. Complexity does not guarantee success. And evolution, in its quiet, relentless way, often favors those who act decisively, predictively, and without hesitation. Now imagine the psychological impact on the humans. The more they watch the spider succeed, the more doubt creeps in. Confidence wavers, stress spikes, neural fatigue sets in. They begin to question not just the experiment, but their understanding of intelligence itself. And that's the most fascinating, almost terrifying part of this study. The spider is not merely winning a contest. It is rewriting the rules in real time. It's forcing humans to confront the uncomfortable idea that intelligence is not a single spectrum where humans sit at the top. It's multidimensional, context-dependent, and sometimes overwhelmingly efficient in ways we cannot replicate. As the clock ticks down, the human's frustration grows. Fingers tremble, calculations falter, and the room fills with a tension that is almost palpable. Meanwhile, the spider moves with eerie calm. Each adjustment, each strike is a testament to a design honed over millions of years, an intelligence perfected not for philosophy, not for art, not for debate, but for survival and mastery of its environment. And in that moment, as you watch it operate, it becomes clear that human superiority is not a guarantee. It's a conditional illusion, dependent on context, environment, and the nature of the task. When stripped of advantage, the spider proves that brilliance comes in forms we are only beginning to recognize.